In this video, we're going to be looking at writing algebraic expressions. So we're going to be given words or a situation, and our job is to change it from those words into an expression. And because we're dealing with algebraic expressions, we know that means that we're going to have variables, operations, and numbers. So let's look at our very first example. We have a 5-inch ribbon is taped to an 8-inch ribbon. What is the total length of the two ribbons? Well, I need to look at this problem and say, okay, what expression would represent this situation? Well, I have a 5-inch ribbon. Sorry, my lines are not very straight. Here is a 5-inch ribbon, and I am taping an 8-inch ribbon to that. Well, to find the total length of these two ribbons, how would I do that? Well, I would take 5 and I would add 8 to that. This is my expression for the first example. Looking at example B, it says a ribbon of an unknown length is taped to a 9-inch ribbon. What is the total length of the ribbons? Well, I know I have a 9-inch ribbon. So this is 9 inches. And then I know that a ribbon of an unknown length is taped to that. So because it's unknown, I'm going to choose a variable, because remember, a variable represents an unknown value. I'm going to choose R just because we're dealing with ribbons. So, well, how would I solve the total length of this? Well, to solve this, I would have to add 9 plus the length of the other ribbon, which is unknown, so I keep it as a variable. This is the expression for example B. To solve it, I would have to do 9 plus R. Okay, let's take a look at a couple more examples. A straw length of 10 centimeters is cut from a straw length 24 centimeters. What is the length of the remaining straw? So I know I started off with a length of 24 centimeters. So this whole thing was 24 centimeters. I then cut 10 centimeters off, sorry. So we're going to say this is my 10 centimeters. It wants to know what was left. Well, how would I find what was left? Well, I would take my 24 and subtract the 10. That would tell me what's left. This is the expression that would tell me that. Example B, it says a straw length 6 centimeters is cut from a straw length of y centimeters. What is the length of the remaining straw? Well, I know the original size of the straw was y centimeters. I'm using y because it's an unknown value. That's why they said y centimeters. Okay, and I know that 6 centimeters was cut from that. So we cut 6 of it. What expression would show me what's left? Well, I would have to take my original, which is y, and I would have to subtract the 6 centimeters. That would give me the remaining length of the straw. So numbers 1 through 3, these are ones for you to practice. So I'd like you to pause the video and try them. And then once you've tried them, press play so you can see how they were solved and see if your answers were correct. Number 1, the sum of x and 10. So I know that sum means addition. So I'm going to be adding. Well, what am I adding? I'm adding x and 10. This is the expression for the sum of x and 10. Our next example, number 2, it says the difference 7 less than y. it's very common for people to say, well, less than is subtraction. So I have 7 minus y. But this is incorrect. When we're looking at the words less than, or greater than, maybe write a side note in your notes. This is going to switch the values. It's going to flip-flop them. So instead, my expression is going to look like y minus 7. So these two are swapped because it says less than. If you think about the way you use less than in a real situation, you say, if you are 5 years less than 12, well, to figure that out, you would do 12 minus 5, not the other way around. So it's important whenever you see less than or greater than, these two values get flipped. For number 3, it says Jim is Z years old. Part A says his brother is 4 years older than Jim. Find his brother's age in terms of Z. When we see in terms of Z, all it's saying is write an expression that has Z in it. So I know that Jim is Z years old and his brother's 4 years older. Well, to find his age, I would have to add 4 years to Jim's age. Part B says that his sister is 3 years younger than him. Find his sister's age in terms of Z. Well, if Jim is Z years old and his sister's 3 years younger, I'm going to be subtracting 3 rather than adding. All right, we're going to move on to some more examples. It says there are 12 crackers in a box. How many crackers are there in 2 boxes? Well, when we take a look, we have 1 box, 2 box, and each one has 12. There's a couple ways we could solve this. We can do 12 plus 12, right? Or we can do 12 times 2. This is an expression that represents this situation. Let's look at part B. There are Z crackers in each box. How many crackers are there in 4 boxes? Well, here's 1 box, 2 box, 3 box, and 4 box. Each box has Z crackers. They're Z's, not 2's. So instead of doing Z plus Z plus Z plus Z, I know that repeated addition is the same thing as multiplication. So I can just write 4Z. This expression represents what was happening in this situation. So we have a 12-inch rod is divided into 3 parts of equal length. What is the length of each part? So I have a 12-inch rod. And if I'm breaking it into 3 parts, what's really happening is I'm taking 12 and I'm dividing it by 3. That would tell me the length of each part. But it's important that we remember we do not write it like this in 6th grade anymore. Instead, we would write 12 divided by 3 or 12 divided by 3. And the reason I did not solve this is because it's not asking me to solve. What I'm doing in this chapter is I am just finding the expressions. Part B, a rod length of W inches is divided into 7 parts of equal length. What is the length of each part? Well, I know that the length is W inches, so an unknown value. I'm breaking it into 7 pieces. So what would that look like in expression? How would I solve this? Well, I know I'd take my entire length and I divide it by the 7 pieces, and that would give me my value. Go ahead and solve these 4, 5, and 6, and once you're done, unpause the video and you can check your answers. Number 4, the product of z and 6. Well, I know that the product means that it's an answer to a multiplication problem. So I'm going to be multiplying, and I am multiplying z and 6. The problem with what I wrote here is this is not how we write it, okay? In 6th grade, remember we said we either use the dot or we use parentheses. But now that we're working with algebra, whenever I have a number and a variable being multiplied by each other, it should now look like 6 times z. Because remember, when we have this coefficient and the variable touching, it means that this is being multiplied. So 6 times z. This is what the expression should look like. Our next one says the quotient of w and 8. Well, I know quotient means division. And what am I dividing? Well, I'm dividing w and 8. The next one, it says Mia bought a pair of shoes for $P. She bought a dress that cost 5 times as much money as the shoes, and a belt that cost 1/4 of the price of the shoes. Well, part A says find the cost of the dress in terms of P. In terms of P means just I need to have P in my expression. Well, I know the shoes cost $P, and the dress cost 5 times as much. But I'm not going to write P times 5 because this is not how we write it in algebra. Instead, it should be 5 times P. And part B says find the cost of the belt in terms of P. Well, I know that the shoes cost P and the belt cost 1/4 of the price of the shoes. Well, P is the price of the shoes. So to find that, I can either take P and divide it by 4, or some of you might have done 1/4 times P. Both of these are correct.